Hello and welcome to this Podar Learn Club. In Podar Tutorial Club, we will discuss about circle theorems. This is a circle and we have drawn one chord. This chord divides the circle into two parts, major segment, minor segment. In major segment, angles in the same segment are equal. Suppose we consider major segment, and in major segment if we draw angles with the help of chords, one angle is drawn, second angle is drawn, third angle is drawn. So all these angles are in the same segment, so these angles must be equal. So angles in the same segment are equal. Similarly, we can draw angles in the minor segment also. So in minor segment, all angles will be of equal size. Here there are two angles and both are equal because both are from the same segment. If you draw this chord, then with the help of this chord, two angles are drawn here, and these angles are also in the same segment, so these are also equal. So this is very important to learn, that angles in the same segment are equal. Now we consider another circle theorem, another important term which you have to remember. So this is a diameter of the circle, and this diameter divides the circle into two equal parts. With the help of this diameter, these three angles are drawn, and these angles are in the same segment. So with the help of the diameter, we have drawn these three angles, and you see these angles are equal because angles in the same segment are equal, and all these angles are of 90 degrees. So the angle in a semicircle is 90 degrees. Come to the next point. Consider a chord and we draw one angle in one segment, and with the help of the minor segment we consider one angle at the center. So angle in the center, angle at the center is twice the angle at its alternate segment. So the angle at the center is twice the angle at the circumference. So this is very important to remember, that angles at the center is twice the angle at its alternate segment. Now come to the next circle theorem that is also very important. This is a cyclic quadrilateral because each and every vertex of this quadrilateral is on the circle. But if you consider this quadrilateral, you will see that this point is not on the circle. So this is not a cyclic quadrilateral. Now this is a cyclic quadrilateral, and you are seeing that the opposite angles in a cyclic quadrilateral, the sum of these opposite angles must be 180 degrees. So if this angle is 86 degree, then definitely this angle will be 94 degrees, so that the sum of these two angles will be 180. Similarly, in other side, sum of these two angles will be 180 degrees. If one angle is 110, then other angle is 70 degrees. So these are the points very important. Now you consider a tangent to the circle. This line touches the circle at one point, and the point of contact, if you draw one radius, then this radius will be perpendicular to the tangent at the point of contact. So this is the tangent, and if you start from the point P, another tangent from other side of the triangle of the circle, then the length of the tangents must be equal. So this length must be equal to this length. So the length of the tangent to the circle are equal, always equal. So if you join the point P to the center of the circle, suppose this angle is P, and if you join the point P to the center of the circle, then this line divides the angle into two equal parts. Suppose if this angle is 30 degree, then each part will be 15 and 15. So this is very important to understand. This is the basic things to understand. There is a circle, there is a tangent, and one chord is drawn through the point of contact. This chord makes with the tangent one angle, and this angle must be equal to the angle formed on the other side of the chord. So these two angles must be equal. Similarly, here also these two angles, this angle must be equal to the angle at its alternate segment. These angles will be equal. This is the basic thing to understand. So alternate segment